Okay, so this is my physics final. For chapter 11, I did problem 11. So I was given a few givens. The first mass, which was 4 kilograms, the second mass, which was 3 kilograms, velocity, which was 5 meters per second, and then the length, which was 1 meter. So I was trying to find the magnitude of angular momentum of the system. So I used the formula L equals mass 1 plus mass 2 b times r, velocity times radius, and then sine theta. So that was the formula I used. So to find theta, I was told that the velocity and the radius vectors were perpendicular, so I knew it was 90. So sine 90 degrees would be 1. So also I knew that the radius was like is the distance between each of the mass and the origin, and the r would equal half the length of the rod, so that would be L over 2, which equals r equals 1 over 2 then, because the length equals 1. So then I substitute the numbers in for the formula I put down, and then I got 17.5 because I get 7 times 2.5, and it's kilograms meters squared per second. But then I realized like the L vector equals 17.5 k hat kilograms times meter m squared per second. This is because I realized that it was in the z-axis because it was perpendicular to the radius and velocity vectors in the plane. So for chapter 12, it was I did problem 11. It was like a beam problem where there were two people, Sam and Joe. They each had different forces, and they were standing different distances apart. Joe was standing 1.8, as you can see, and Sam was standing 2.8 from the center of gravity, both in meters. And the whole beam was like 4.6. So the center of gravity, it was 450 newtons. So that was like the force of the whole system. And the next part on this page. So in the y direction, I tried to find the different people's forces. I know it's going to be in the y direction because both of them are going to be pushing down on the beam with their force. So I did the sum of Fy equals Fjo plus Fsam minus 450, which was the center of gravity. And then 450 equals the two forces of the guys, the people. So because it's the center of gravity, it's like and then the sum of the torque equals the force times the distance. So I plugged it in, and then so I got the torque equals force of Joe 1.8 minus force of Sam 2.8 equals 0. So then I added Sam to the other side and divided 1.8 to try to find Sam. Force of Joe equals Fsam 1.56 when you divide the 1.8 to the 2.8, and then you can substitute the Fsam 1.56 into the Fjo to the original formula where we had Fjo plus Fsam equals 450, and then you get Fsam 1.56 plus Fsam equals 450. You can add the Fsam, you get Fsam 2.56, and then you divide that to the 450, and then you get 176 newtons for Fsam. Then you can just subtract the 450 by the force of Sam, which was 450 minus 176, and then you get 274 newtons for the force of Joe. Chapter 13, I did problem 8. So for this one, we were trying to explain why a gravitational force of 1 Newton can't exist between the two spheres separated by 1 meter. So we were given a lot of data, the force of gravity, which was 1 Newton, the radius, which was 1 meter, and then G was a constant for the universal gravitation constant, and that was 6.674 times 10 to the negative 11 newtons meters squared over kilograms squared. So we used the formula that were given. I found the force of gravity equals G times m, the first mass and the second mass, over radius squared. And then I realized this formula was gonna work, so that's why I picked it. So to show why this situation does not work. So I was trying to find, as I explained, I was trying to find why that 1n force does not exist. And this is a model of like the two spheres, the 1n, and then the 1 meter distance between them. And then I realized that all masses equal each other in this situation because they're both the same. They're both equal to the same thing. So then I could just simplify the equation to Fg equals G m squared over r squared. And then I realized I have to find mass for the density, because if I find the density and the density is way out of reach, then the situation will not work. So I got the mass, and then I turned the equation around to get it so it equals the mass, and then I plugged in the numbers I had, which worked, and then I got the mass, and then I tried to find the density then, and since the spheres are the same, I plugged in the meters, or the mass I mean, and then I plugged in the radius for like the volume. Since the sphere was 4/3 pi r cubed for the volume, so I just plugged in numbers basically, and I got a really huge number for the density. And then I realized that it would be way too dense for any like material, like, and it basically, the situation did not work because of that, because of the density. Chapter 14, I was trying to find the mass of gold. So the givens were L equals 4.5 length, 1 meter. I just changed the units, so I changed it from centimeters to meters for all of them. So I just did a simple conversion to do that. 1 meter over 100 centimeters for all of them, for the width to 11 cm, 1 meter over 100 cm, and then yeah, I just basically did that for all of them. And for the height too, yeah, I got 0.26. And then for the density of gold, that was just like in like one of the tables in the book, so I just took that. And then I realized I have to find the mass, so I used the formula for volume, and then I plugged it in length times width times height, and just plugged in the numbers and with mass. So then I got a mass cube, kilograms from over mass cube, like 0.00129 for the volume. And then basically all I had to do was then I realized that I said the mass equals the density times the volume. So I literally just plugged it in, and I got 19.3 times 10 to the third, and then times 0.00129, and then I got 24.8 kilograms for the meters. Yeah.